Okay, so let's first think. Let's first think about the distances. Remember, we made the remark that we can basically get a data frame, and we can come up with some kind of distances for this. So at that time, we mentioned that we can have a distance matrix, right? So let me introduce a data frame to you guys. It is nothing but a portion of your diabetes data set. I have only like 6 items here, 6 data points, because I want to make it short so that you can understand how the matrix can be represented in a single shot. So I want to keep the matrix size smaller so that you can really see every pair of distances that you can have from this little data frame. Okay, so if you are really curious about the distance matrix, let's call this guy dm. It is also for data mining, right? So I can use my distance function, and I can call this the distance function df, and dm becomes what? A distance matrix. So if you need to use a hierarchical clustering function in R, which is basically h classed, all right? So this guy will have an input, which is going to be a distance matrix, okay? Let me see if we have yeah, it should be over here. So it needs some kind of distance matrix. Make sure that you are passing a distance matrix to this function. And these are the distances for each pair of data points that you have. Looks like there's a distance between 1 and 2. There's a distance between 1 and 3. So I don't have the distances for the data points to themselves. So I just get rid of all the zeros, like I mentioned in the example during the lecture. And I also work with the lower triangular matrix, as opposed to holding the whole matrix, which is a symmetric matrix. So there is no point to hold the whole matrix. Okay, after this point, what you can do, you can just say, hey, I need a hierarchical clustering, and you can just run this function on this distance matrix, which can be called dm. And if you want to see how this worked out, you just plot it. So it looks like you have data points, you have like 6 of them, and this is the dendrogram that you come up with. So let's try to replicate this example for a data set, which is a toy data set. I provided to you guys. It is called distances CSV. I automatically have this data frame with the distances calculated. So you don't have to really worry about the distance or the data frame, because it is already a distance matrix for the example I provided for you in the lecture. So these are the distances between any 2 pair of cities, starting from Chicago, Boston, New York example. So I'm going to read this. So initially, it is nothing but a data frame. So I won't be able to, I'm not going to be able to pass this. Yeah, I have this matrix that you can remember from the slides, but I cannot really pass this as a distance matrix to my hierarchical clustering function, which is high classed, okay, H classed. Therefore, I have to make a conversion and say, hey, I'm going to do a casting here, okay? We do a casting, some kind of casting from data frame to distance data type. Okay, so I just run this. So this guy, if you want to inspect the details, that is nothing but a lower triangular matrix, just a copy of the earlier thing, and you just represent this with a lower triangular matrix, and there is nothing symmetric. There is nothing like zeros, and you don't have all the redundant information here. Anyways, so you observe that your distance is 206 between Boston and New York. If you recall the example, we started with this distance. And now what I'm going to do is I'm going to call my hierarchical clustering function, and it is going to work on this distance matrix. And then I need to specify a method. So if you recall the single link, complete link, and methoid, and so on. And now, since the example I provided during the lecture is using single link, I'm going to stick to the same measure. Okay. Therefore, I'm going to run this. Looks like I got the clusters. So this HC will be like an object, so in which you can get several things, right? So it'll basically have everything. So you can have all the information that is provided, okay? If you wanna represent this pictorially with a dendrogram, maybe I should first draw this one with the default representation. So you see they are not really aligned here at the bottom. It is really proportional to the distances, which is represented with the height axis, which is on the y-axis, okay? So I have the height measure, which is the height of your tree in this context. And these values are nothing but distances from my matrix. Of course, these are the lowest ones. So if you just pick a cluster here and check the Chicago here, so it looks like this length is the distance between this cluster and this data point. So you can basically think along the same way to see the distances. If you want them to align at the bottom, you may want to do the following, okay? So it will basically give a nicer picture. Okay, so from here you can just infer that, okay, New York and Boston in the same cluster, and then DC joined them, and then Chicago joined them, and so on. Okay. Another thing that you can do is, well, in this case, I don't really know how many clusters I have. It is just the way it produced my clusters. So I know that, okay, I have these clusters, like layer by layer, it is growing, I just merge them and so on. But I don't really know what number of clusters I need. So I may need to look around and see, or I need to ask a domain expert, or if you have a specific task which is designed for a number of clusters, you may want to think of cutting at some level your dendrogram, okay? Suppose I want to apply, let's say I want to get like 4 clusters. In that case, I'm going to call my cut tree function. It is going to cut this dendrogram, this hierarchical structure, and it will produce me 4 clusters. If you want to inspect, if you want to inspect, what you are going to find out is that you have Chicago, DC, New York, and Boston. They are in the first cluster. Looks like Miami is still an outlier, I would say. It is really far apart from those. And what I see also is that Seattle, San Francisco, and Los Angeles, they are forming the third cluster, and Denver is also as isolated. If you recall, I did this cut during the lecture, and we kind of saw that this was the case when you cut at a specific place. So that means if you just cut through here, all right, if you just cut through here, if you can see my cursor, basically this will leave Miami and Denver isolated. So this group will be a cluster and that group will be another cluster. So you can basically play around and try to see different number of clusters as you wish. But essentially, this is the function which is going to work on. And be careful that what you're going to pass is not a data frame. Make sure that you are passing a distance measure. If you want to change it to another method, you can change it, okay? You can change the method to another one. Okay, in that case, you may want to check the help. And for the method, you can see other options. And these are the options like single, complete, average, median, and centroid. If you should remember that from the lecture. Median is nothing but a medoid, okay? So that is the guy which is gonna be in the middle. Okay, let me stop here. I'm sorry. And let me also stop the recording. Where is it? It is